Remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us on today's TechNet webcast, How to Implement Microsoft Hyper-V Server and Intel Virtualization Technology. It is now my pleasure to introduce today's presenter, Keith Mayer. Keith, you have the floor.
Thanks very much, Phil, and good morning, good afternoon, or good evening to everyone, depending on where in the world you may be connecting to our webcast session today from. As Phil had mentioned, my name is Keith Mayer, and I am the lead learning consultant with Microsoft, supporting Microsoft's enterprise partner and enterprise customer community to develop effective learning programs and training programs on the latest Microsoft technology. Today's session is going to be focused on Microsoft Hyper-V server virtualization when used on an Intel VT platform. The Intel VT platform, we'll see, provides hardware-assisted virtualization to improve the security, stability, and performance that server virtualization can provide in a Microsoft world on an Intel server platform. To give you an idea of what we'll be talking about today, I'm going to switch to my next slide. And what we will be covering is first an overview of Microsoft's virtualization portfolio to give everyone a strong feel for where server virtualization fits into the overall spectrum of Microsoft virtualization technologies. Server virtualization is oftentimes what most people immediately think of because of the press it's garnered in the market today when thinking of virtualization solutions. But as we'll see, Microsoft has a complete portfolio. For the remainder of the session, then, we'll be going deeper specifically on the server virtualization topic, looking at an overview of Hyper-V and the architecture that Hyper-V uses to virtualize multiple server workloads on a single set of physical server platforms. We'll also specifically be highlighting the capabilities of Intel's virtualization technology, or Intel VT for short, in terms of the hardware-enabled virtualization features it provides in terms of processor virtualization, memory protection, and connectivity hardware-assisted virtualization, also known as Intel's virtualization technology for connectivity, or VTC. Finally, we'll finish up looking at the requirements for getting Hyper-V running within your Intel server data center environment and going through two demos, one on the installation and management of the Hyper-V server role in Windows Server 2008, and a second demo specifically focused around high availability, taking advantage of the built-in Windows Server 2008 failover clustering feature set, also known as quick migration. So let's start looking at Microsoft's complete virtualization portfolio first. And as we had mentioned just a few moments ago, server virtualization, over in the right-hand upper corner of your slide, is the area of virtualization that many people tend to relate with virtualization technologies in general. However, Microsoft does provide a complete portfolio that the Intel hardware-assisted features in both processors and network chipsets look to augment to improve performance and security. Starting in the lower left-hand corner of our slide, we have desktop virtualization, or the ability to run multiple desktop operating systems on a single physical platform. And there's many different ways of being able to deliver that virtualized desktop in the Microsoft portfolio. We can deliver it on existing workstations using Microsoft's virtual PC technology. We also have the ability to deliver that over the network using Microsoft's Virtual Desktop Initiative feature set. And for more information on desktop virtualization, I'd encourage you to go to www.microsoft.com/virtualization, where some of the desktop-specific virtualization initiatives are spelled out in greater detail. So the desktop virtualization features are leveraged by the Intel processor platform to provide improved security, improved stability, and be able to deliver more desktop more virtualized desktops down to end users in a consolidated VDI environment. Presentation virtualization, just above on our slide to the left, leverages a tried and true technology, Microsoft Terminal Services. And here's where the larger scale Intel processors, particularly the 5300 and 7400 processor families, really provide great features in being able to scale out the number of individual desktop sessions that Terminal Services is delivering, so that a single server today on an Intel platform can literally deliver hundreds of concurrent presentation server terminal service virtualized sessions down to users. Moving up to the top of our slide, we have data virtualization, the ability to store pieces of data that relate to a user's experience with the network, such as their user profile, or personal data that may be stored in their documents folder. The ability to redirect that data to a safe haven on the network is data virtualization. And certainly while this is not virtualizing workloads or running processes, it's still virtualizing network resources that users would access. And here's where the Intel network card chipsets provide great features in improving overall performance in terms of the amount of data that can be safely shipped back and forth across the network. The Intel network chipsets, as we'll find out in more detail when we talk about VTC in just a few minutes, have acceleration technology built into them to be able to deliver an increased amount of network data over your existing network infrastructure by moving the heavy lifting of network I/O closer down into the hardware and relying less on software drivers. Down towards the lower right-hand corner of our slide, we have application virtualization. Application virtualization has also generated a ton of interest in the market over the last 18 months. It serves to change desktop management as we know it in a typical enterprise environment by taking individual applications that at one point may have conflicted with one another when run on the same desktop workstation and isolating them at an application level into their own protected application bubbles. That way, applications that previously conflicted with one another no longer can see and interact with each other, so that we can run, in many cases, multiple versions of the same application or older, otherwise incompatible versions of applications together on a standard desktop platform. The application virtualization piece was formerly known by Microsoft as soft-grade application virtualization, and Intel's vPro desktop management technology set can be leveraged together with application virtualization to provide a truly dynamic experience that entails both management of the applications as well as the desktop hardware supporting those applications in a centralized manner within an enterprise environment. For more details on application virtualization and Intel vPro, there is also another webcast coming up on Friday, November 19th, this coming Friday, specifically on that topic. So having given a brief introduction to the complete portfolio of Microsoft virtualization technologies, let's now focus the rest of our session around server virtualization. And specifically, Microsoft's Hyper-v solution for server virtualization. Microsoft Hyper-v is a new server virtualization solution that's been made available with the release of Windows Server 2008. In terms of server virtualization, Hyper-v allows multiple server workloads that were once resigned to running on separate physical servers to run on a consolidated small number of physical hosts, reducing our overall investment in server hardware technology. Traditionally, some of the challenges with server virtualization and running servers, traditional servers within the data center, are listed on our slide as underutilized hardware being one of them. In fact, based in recent studies, some interesting results have been seen in typical data center environments today that do not have an effective server virtualization solution, the overall average utilization on those servers generally is somewhere in the neighborhood of 20 to 30%. And there's really a variety of reasons, but one of the chief reasons is that hardware capabilities, the performance of the capacity of hardware has seriously outstripped the ability for software to really drive it if we're only running a single server workload on each of the servers in our data center. For that reason, many environments are looking at server virtualization as really getting the best utilization out of their hardware investment. Kind of a novel approach based on my experience as an IT pro 5 years ago. We all would have been in our data centers looking at physical server utilization hovering around 20 to 30% and rejoicing that our servers are performing wonderfully. Today, certainly with increased economic and cost pressure, we're now taking a second look at that and realizing that there's perhaps a great expenditure in hardware that's really not being effectively utilized. Power consumption is another challenge, certainly, in large data center environments. In fact, an interesting side note on power consumption is that whether or not you use Hyper-V server virtualization to consolidate server workloads, one of the interesting facts with the latest Intel active management technology that's present in the current shipping versions of Intel server chipsets, and just Windows Server 2008 alone, enterprise data center environments have seen an 8%, as much as an 8% drop or reduction in overall power costs. Now, we add Hyper-V server virtualization on top of that, where we're actually consolidating multiple physical server workloads onto a smaller number of servers, and certainly our power consumption and overall savings can only increase from there. The other challenge that we have is minimizing planned and unplanned downtime. And in a traditional environment, in the old days, where we weren't using server virtualization, this may have been less of an issue because we had generally in those days one server workload running on each physical server. And if something were to happen where one of those physical servers were interrupted, it would only affect that one workload. Well, as we consolidate multiple server workloads onto a small number of physical servers, that challenge becomes more monumental. Because now a physical server running multiple workloads, if that physical server becomes unavailable, it takes several different workloads down with it, which could, depending on what those workloads were, cause a catastrophe within the data center environment. So high availability is a key component of any server virtualization strategy, and it should be carefully considered when you're implementing server virtualization to ensure that the failure of a physical server that in your environment has the ability to recover those workloads onto the remaining servers. Windows Server 2008 not only supports Hyper-V for the server virtualization feature set itself of consolidating those workloads, but it also supports failover clustering out of the box with Windows Server 2008 Enterprise and Data Center Edition to make those virtualized server workloads highly available across a farm of multiple Hyper-V servers. So then the solution that Hyper-V really brings to the table is being able to use server virtualization to drive up the effective utilization of hardware on our server platforms. The Hyper-V hypervisor architecture is a very efficient, thin layer of software that manages the ability to interact with hardware and virtualize multiple server workloads. Now that hypervisor software, as we'll see, is, I said, very thin, less than 1 meg in size, and it's not part of the operating system. It actually stands outside of the operating system so that it's not susceptible to normal operating system security attacks. Pairing up that hypervisor-based architecture, which in software has been optimized for secure and efficient virtualization of multiple workloads then, with hardware-enabled technology like the Intel VT hardware-assisted virtualization features together combine a solution that allows us to squeeze as much out of our existing physical servers as we possibly can. In fact, the overhead today with Hyper-V and Intel VT together is very minimal. In many cases, it's not even measurable. It's so small, and it's been estimated to be somewhere in the neighborhood of 2 to 4% overhead on the platform. But take into account that we're able to now take advantage of 96% of the horsepower within our servers, instead of in the old days, as we said, that average in a non-virtualized environment being that 20 to 30% utilization. So we can use this approach to consolidate effectively multiple physical systems and provide integrated management for both the physical hosts as well as the virtual hosts. Now, from a management standpoint, that's another important area to keep in mind when you're planning any server virtualization solution. In fact, some additional research that's been done inside enterprise organizations that are using server virtualization technologies today have found that virtualization being deployed without an effective management solution around it can cause a whole host of additional problems that make matters even worse in your enterprise environments. One of the most well-known problems without effective management over your virtual workloads is the concept of server workload sprawl, because virtualized server environments make it very easy to spin up new server workloads without an effective management layer in place to really control that and police the number of servers you're maintaining virtually. You can easily grow from managing 100 server operating systems to thousands of server operating systems in just a short while. And you might think, well, but my number of physical servers hasn't increased, and that's all well and good. The number of physical servers may be much lower than it was in the past based on consolidating to reduce costs and to reduce hardware maintenance efforts around those servers. But the mere fact that you have a larger number of even virtualized server operating systems still lends itself to other operating system maintenance increases, like patch management and configuration management that's done at the operating system layer. So in the Microsoft world, we've got two different management technologies. Out of the box with Windows Server 2008, we've got Hyper-V Manager and Failover Cluster Manager, which we'll be showing towards the end of today's webcast. And those are intended for small to medium server virtualization environments. We're dealing with a few host servers running Hyper-V. If you're extending it to a larger environment where you have 5, 10, 15, 20 or more Hyper-V host servers hosting virtualized server workloads, the System Center product from Microsoft is the suite of management technologies that's designed to embrace Hyper-V and be able to centrally manage those resources from an enterprise library and farm level. So we won't be talking about System Center Virtual Machine Manager specifically in detail today. However, I'd encourage you to go out to the Microsoft.com/webcast URL that Phil had mentioned earlier, because there's a number of great System Center webcasts that can provide more details on that management layer. So in summary then, Hyper-V, Microsoft System Center, and Intel VT are really the three components that you should be looking at when planning your overall server virtualization solution. Now, we talked a little bit about Intel's virtualization technology earlier in the session, Intel VT, as providing hardware-assisted virtualization for better performance, better security. The Intel VT architecture, the Intel VT feature set, is included with the current shipping Intel server CPUs and server chipsets. And in terms of processor support, they provide quad-core 2 and 4 socket capabilities for very large capacity virtualization. That means that in a small U rack mount server, you could have as many as 8 to 16 cores to deal with, and those cores could be given to each of your virtual machines. With Hyper-v, Hyper-v supports virtual machines that can support 1 or as many as 4 logical cores being allocated to the VM. So the Intel VT, the reason that it provides this higher performance is it eliminates the need for software to translate memory address spaces and instructions between multiple virtualized workloads that run on top of the same hardware. Intel VT supports that same type of binary translation in hardware, the same results, I should say, of that binary translation in hardware, so that doesn't need to be performed in software. And that's one of the biggest reasons that Hyper-v has such an increased capacity for virtualizing server workloads over the preceding Microsoft Server Virtualization solution, which was Virtual Server 2005. Now, beyond just processor support, though, Intel VT offers some other hardware-assisted virtualization capabilities. For instance, Intel VT Flex Priority is a hardware technology that prioritizes interrupt requests coming from the various VMs so that it can be handled in as streamlined a manner as possible. That allows the ability for the underlying hardware platform to have some better visibility into the demands from each of the guests that are running on top of that platform, so that one guest doesn't consume all of the hardware resources and lock out other guests. In addition, Intel VT for Connectivity is a hardware-assisted feature set available in 1 gig and 10 gig Intel Ethernet network chipsets. Those network chipsets could be either integrated onto your server system boards, or they could be additional add-in cards. Intel VTC provides accelerated transfer of information. We talked a little bit about that in terms of data virtualization. That I/O acceleration technology, or IOAT from Intel, that's part of the virtualization technology for connectivity, also has a huge benefit here with Hyper-v. Because as we think about virtualizing multiple server workloads over the same physical network adapters that are on our servers today, we're likely to see a much higher network utilization off those adapters than we do in the single server workload to physical server ratio of non-virtualized environments. So that in a non-virtualized environment of servers with 1 gig network cards in them, again, we're likely to see in that environment very low utilization. As we start stacking multiple workloads to the same NIC, technologies like VTC are important. Going beyond just mere acceleration, though, Intel VTC offers a roadmap for future support down the road. In addition to accelerating overall network performance, Intel VTC offers today in hardware some pretty advanced features for queuing and switching packets in hardware between virtual machines, a technology called virtual machine device queuing. And it also offers I/O assignment directly to I/O request assignment directly to individual virtual machine guests. So that capability is provided in hardware today, and as the Intel and Microsoft virtualization partnership works forward, they'll be looking to incorporate those same types of features in a future release of Hyper-v. So this high performance really provides extra capacity that we weren't able to tap in older server platform technologies. The stability and reliability also is heavily increased because much of what prior server virtualization products were doing in software is now moved down into hardware, where it can be performed with greater robustness, greater performance, greater security. So the VT technology set is really optimized for these embedded hypervisor technologies and for more and more hardware-assisted technologies that expose hardware in a virtualization-aware manner. So some of the new usages then for Hyper-V that many environments would not have deployed virtual server for are heavy production server workloads. We see lots of environments moving heavy production server workloads for database, messaging, file, and whatnot over into Hyper-V to have better control of being able to consolidate those workloads. Hyper-V is also a great solution for business continuity, disaster recovery, where we're trying to reduce the footprint perhaps at a DR site for the number of physical servers that need to be maintained, as well as for branch offices. Hyper-V is a great solution for reducing the number of physical servers that are necessary, but still providing all those critical services through virtualized server workloads to our branch office users. So when we look at these server virtualization usage scenarios then, we talked a little bit about them, and I've got some summaries on this next slide of production server, consolidation, really being able to take those heavily utilized services and consolidating them down on a smaller number of physical hosts. That whole business continuity, management, being able to take, even if in our data center today, if we're still running physical servers, many environments that have not developed an effective server virtualization solution set today have moved to their initial steps of deploying server virtualization for disaster recovery so that their IT pro staff can really get comfortable with that technology and be able to support it. Certainly, some of the traditional server workloads still apply, like test and development. And by leveraging tools like System Center and Hyper-V failover clustering, we have the ability to have truly a dynamic data center where we can easily move server workloads from one host to another without resorting to an extended period of downtime for our users, allowing us to really collapse those maintenance windows and be able to position our hardware investment for best utilization by the services we're currently running in our environment. So when we look at the Hyper-V architecture then, we see that down at the bottom we have our hardware. That's really where the Intel VT technology is embedded. It's embedded in the hardware. And one of the requirements that we'll talk about is that when you install Hyper-V on an Intel chipset server, you may need to turn those features on if they haven't already been turned on by your OEM. That activation takes place inside your BIOS generally on your servers. We'll talk about that in a little more detail as to the specific components that need to be turned on to activate Intel VT. On top of the hardware then is where the Windows hypervisor sits. So when we install the Hyper-V role, what it's actually doing is installing that hypervisor code base so that when our servers boot up, after they go through their hardware power on self-tests, the next piece of code that they load is the hypervisor. The hypervisor then partitions out that server into multiple areas. A parent partition that holds the original Windows Server operating system that's used for managing each of the virtualized server workloads and managing device drivers. Each of the virtualized server workloads run in separate child partitions. And those server workloads could encompass workloads that are running inside those child partitions on virtualized Windows Server 2008, Windows Server 2003 operating systems, legacy Microsoft operating systems like Windows Server 2000, or non-Windows operating systems like Xen-enabled Linux environments. Hyper-V the Hyper-V team have developed support for the Xen-enabled Linux kernel to support a variety of non-Microsoft Linux operating systems as well. Now you'll notice in each of these partitions, we have components running in user mode and in kernel mode. And down in kernel mode, we have in our parent partition a component called the VM bus, the virtual machine bus. That VM bus is intended to be a high-speed communication path between child and parent VMs, between the child and parent partitions, so that when the child has a device driver request, accessing disk, accessing network, they can use the VM bus to communicate that directly to the parent, where the parent's device driver processes that request. Now, it's important to note that there are some types of requests that the child sends directly down to the hypervisor, particularly calls to the processor itself and memory allocation, memory protection. Those are handled directly through the child partitions down to the Windows hypervisor for increased performance. So you'll see that through this architecture then, we have a lot of flexibility in being able to deploy varieties of applications and operating systems. One piece that we want to be careful of when planning Hyper-V servers is that the parent partition be streamlined for the management of the child partitions only. And what we mean by that is that generally we do not recommend running any network services within the parent partition itself. Services like file services, database services, messaging services, and whatnot should really be run inside the child VMs. Otherwise, the architecture that Hyper-V is built upon can become in contention between the requests of the parent partition and the requests of the child. So really any of those server workloads in a Hyper-V standpoint, Hyper-V architecture, you want to be sure to run only within the child partitions. The other piece in optimizing our parent partition is to ensure that we're using the smallest set of installed components on our parent partition. One way of achieving that is by leveraging a Windows Server installation choice called Server Core. Server Core is the installation option for the Windows Server operating system when you're installing Windows that strips down that parent partition to the base required code to support Hyper-V and to support the child partitions. That reduces the memory and resource requirements for that parent partition tremendously. And installing the parent partition with the Server Core option is a very common way of deploying Hyper-V within large data center production environments. One point to note about the Server Core installation is that Server Core does not provide a graphical window manager. It does not provide Windows Explorer. So that from a parent installed with Server Core, you cannot manage Hyper-V and the various child workloads that are virtualized on it. Instead, you have a separate machine in your data center that's used as your management workstation or server that has the management tools on it and manage those Server Core servers remotely. Also keep in mind that if you plan to cluster Hyper-V servers and you're using the Server Core option, the Server Core installation option has to be installed on each of the physical hosts within that cluster. Otherwise, when you try to cluster the servers, they will see a difference in the operating system installation, and the cluster administrator will prevent those servers from clustering together. So we've talked a bit about the hardware architecture of Hyper-V. The next slide goes into a bit more detail on Intel's virtualization technology for connectivity. And we touched on this briefly a few moments ago when we were talking about Intel VT in general. So VTC, the virtualization technology for connectivity, as we said today, it really is designed to improve communication between the Intel CPU and the I.O. devices that are running network I.O. From that standpoint, through its acceleration technology today, it offers great benefit to have VTC-enabled network cards in your Windows Server 2008 Hyper-V hosts. Also, In addition to I/O acceleration technology, as we said, VTC encompasses some other more advanced hardware technologies that are not supported directly by Hyper-V today, but are certainly future goals from a support standpoint. And those technologies are virtual machine device queuing, or VMDQ, and VMDQ supports the equivalent of a layer 2 network switch inside your network card chipset, so that it can basically pre-sort traffic going to and from each of those child partitions to reduce the level of interaction that the operating system has to play in relaying traffic back and forth. In addition, we have single root I/O virtualization, which allows the ability to expose hardware devices in a more direct way to each of the VMs. So those features are on the future roadmap, future plans. They're currently supported in Intel hardware, and by leveraging this technology today in your current Windows Server hardware deployments, you won't have to worry about swapping out network cards down the road at a future point when Hyper-V supports those features. In addition to the network-facing features that we commonly think of with heavy network I/O, another area that may be of benefit is that VTC also involves the ability to perform iSCSI offloading for storage networking improvements. And iSCSI offloading is a great feature paired up with Hyper-V because it's an underlying storage technology that can be used by Hyper-V clusters to provide high availability with failover clustering of those virtualized server workloads. So the overall benefits of VTC then: increased system performance, lower CPU utilization. Now let's talk about installation and management of Hyper-V with Intel VT. So the requirements, we said we had to have a server chipset that had Intel VT support, and that's true. Generally what you'll find is that with servers that are shipping today, Intel VT is commonly supported on the Intel chipset servers, but may not be enabled by default. So the first time you're doing your hardware prep on your servers, if you plan to install Hyper-V on those servers, you want to make sure you boot into the BIOS setup and enable Intel virtualization technology, or Intel VT. In addition, while you're in the BIOS setup, there's another BIOS-related feature that also needs to be enabled. It's a memory protection feature that Hyper-V relies on, called Execute Disabled in the Intel world, or Hardware Data Execution Prevention in the Microsoft world, or Hardware DEP. That's the second BIOS option that needs to be enabled. In addition, you need to make sure that your server is capable of running a 64-bit operating system, which generally servers that you purchase today are all capable if they're based on an current Intel server chipset, and that the version of Windows Server 2008 that you install on those servers is an x64 64-bit edition. So that gives us 4 common choices of operating system. We can install Windows Server 2008 x64 Standard Edition, Data Center Edition, Enterprise Edition, or a new choice called Windows Hyper-V Server. Windows Hyper-V Server is a scaled-down Windows Server SKU. It's a scaled-down Windows Server product offering that's specific to supporting Hyper-V server virtualization, primarily intended for small data center environments or branch office environments. It does not have all of the robust features of the full Windows Server operating systems for supporting other server workloads, and there are some additional limitations. In fact, we'll be talking about those limitations and a comparison of each of these server operating systems in just a few more slides. So that Microsoft Hyper-V packaging then, really, it gives us an additional choice. We can buy Microsoft Hyper-V Server, which is this prepackaged version of Windows operating system streamlined for Hyper-V without any of the other Windows network service support built into it, or we can install Hyper-V as a role on top of a mainstream 64-bit edition of the Windows Server 2008 operating system, standard, enterprise, or data center. We'll be looking in our demo at the second option, the Hyper-V role in Windows Server 2008, but I did want to provide a comparison of the advantages and limitations of each of these installation choices and product options for you, and I've got that on the slide that's currently displayed. So as you look across the slide, you'll see that Hyper-V Server still will support up to 4 processor sockets and 32 gig of physical memory, similar to Windows Server 2008 Standard Edition, but that it doesn't offer some of the more enterprise features. For instance, it doesn't offer high availability clustering. It doesn't offer a graphical administrative UI. It's command line only. It requires management to be provided remotely. It has the same number of running VM guests, up to 128, as the other editions, but it doesn't come with any built-in Windows Server licenses. And this may be something new if you haven't recently looked at the virtualization licensing in terms of Windows Server operating systems with Windows Server 2008. But Standard, Enterprise, and Data Center Edition all include a certain number of free Windows Server licenses when you install those products. The Standard, you can install one child running Windows Server 2008 without paying for that additional child license. Enterprise Edition includes 4 child operating system licenses, whereas Data Center Edition includes an unlimited number of child operating system licenses. One other point to note in evaluating these options is that Microsoft Hyper-V Server, that first column of product option, is available as a free product download from the www.microsoft.com/virtualization product page. So it is available free, but it does not include any additional server operating system licenses. So now I'd like to go through some information as a demo on installation and management of Hyper-V. And what I will do is take a few seconds just to switch over to my desktop environment. And on my desktop environment, we should see Windows Server 2008 Server Manager. Using Windows Server 2008 Server Manager with a full version of the Windows Server operating system, Hyper-V is installed as a role. So the installation order normally would be first set our BIOS options for enabling Intel VT and Intel XD, the memory protection. After enabling those BIOS options, you'll want to shut down, power off, and then power on the server. And the reason for that is the BIOS options may not take effect on your server platform if you simply do a warm restart. So a cold restart is necessary. After performing that change in the BIOS and doing a cold restart, you would install the appropriate version of Windows Server 2008 based on the features and licensing that you're looking for. And then use Server Manager to install the Hyper-V role. Now, I have to caution you, prior to using Server Manager to install the Hyper-V role, I would highly recommend that you go out to Windows Update from that server and download the current updates for Windows Server 2008. One of those updates in particular is an update to the Hyper-V role that provides a full version of the Hyper-V role with increased stability and security. And so make sure that you do the Windows Update first before installing the Hyper-V role. Once we've gone through Windows Updates then, we go into Server Manager, we use our Add Roles wizard, and Hyper-V would be installed by selecting it, walking through the wizard, and then when prompted, shutting down and restarting. Upon restart, Hyper-v will load up first as the hypervisor on top of the hardware, followed by the first parent partition. Now we said that the Hyper-v hypervisor is very small, and it is. It's less than a meg in size. In fact, in my Windows System 32 folder, I've highlighted the file that makes up the hypervisor, HVIX64, and you'll see that it's currently 718K. So that's the Hyper-v hypervisor that loads up first for hardware interfacing with Intel VT. Along with installing the Hyper-v role, we also have a base tool for managing that role called Hyper-v Manager. Hyper-v Manager is an MMC tool that is intended for managing a small number of Hyper-v host servers, generally 1 to 5. If we're going beyond that, generally we'll want to evaluate whether System Center is a component that we should be including in our strategy, because that's the product that's intended for managing a larger number of Hyper-v servers. Now, Hyper-v Manager can manage one server or, as we said, a small number. If we had additional servers to manage, we could right-click, connect to those additional servers, and add them in. And we'll see we've got 2 servers now running virtual machines. So Hyper-v, in my Hyper-v demo here on server 1, over in the middle, I see my running virtual machines. I have a couple Windows Server 2008 boxes running virtually, as well as a SUSE Linux enterprise server running. Down in the middle area, I see any snapshots that may have been created. I'll switch over to my lab core virtual machine, and we'll see that there's a number of snapshots that have been developed. Snapshots in Hyper-v are similar to undo disks in the older virtual server and virtual PC products. The big difference, though, is that unlike with undo disks, we have the ability to record multiple snapshots as point-in-time copies of what was in memory and what was within the configuration of that VM on disk, its virtual disk, so that we can easily revert back to that point-in-time copy. Snapshots with Hyper-v leverage volume shadow copy services, and if the guests that are running, the child partitions that are running, have applications running inside of them that also support volume shadow copy, such as Exchange or SQL, one of the nice features that Hyper-v provides is a connection to the volume shadow copy service within the child VMs as well. So that when a snapshot is taken, the applications that are running in the child VM are quiesced so that a safe snapshot can be recorded down to disk. Once we recorded a snapshot to revert back to it, we simply apply it, and we can revert back. You also see down at the bottom a summary, a thumbnail of the console screen of each of the VMs as I navigate between them. Now, as I look at configuring my Hyper-v environment, over in the upper right-hand corner, I have an overall actions menu where I can create new VMs and define virtual hard disks and whatnot. I also have the ability to set up virtual networks. This is a new capability that interfaces with certainly the Intel NICs that are on this server. I can define multiple virtual networks, here I have one, that are tied to each of my physical NICs, and I also have the ability to enable VLAN tagging, so that if I had multiple VMs that I wish to run over separate logical subnets for either security or management reasons, but through the same physical adapter, I could do that. And have my Hyper-v servers connected perhaps to a VLAN port or a trunk port on a switch that can separate those logical subnet traffic streams out. So some real nice capabilities. For modifying the settings of any of my VMs, I can simply select my VM and click on the Settings menu. There I have a complete set of choices for either changing or adding hardware. You'll notice that many of these choices are currently disabled, such as memory and processors, because my VM that I've selected is running. While a VM is running, I cannot change my hardware settings. I have to shut down that VM first. So that's just a basic introduction to managing Hyper-V through Server Manager. If we go back here to our presentation, we want to talk a little bit towards the end of our session on high availability. So high availability with Microsoft Hyper-V is certainly an important piece of the equation because, as we talked about a little earlier, in the virtualized environment, the DR value of each physical server goes up tremendously because each server is now running multiple virtualized server workloads. And the failure of one server can be far more dramatic because multiple workloads could be affected. So virtualization and high availability together are two key pieces that you'll want to evaluate along with manageability in architecting your dynamic data center. So some of the high availability solutions that come to bear with Microsoft Hyper-V and Intel VT hardware-assisted virtualization are high availability solutions that provide for both planned as well as unplanned downtime. So for planned downtime, we can take advantage of a failover clustering feature called quick migration. Quick migration allows a Hyper-V host to quickly save the running state of a virtual machine so that it can move that virtual machine over to another host. In order to take place, in order for that move operation to take place, the virtual machine, the child VM, does need to be stored on external storage, such as a storage area network, that all of the hosts in the cluster have access to. One of the Intel features that assists with this migration of VMs is a feature called flex migration. And what it provides is a future-proofed path to future Intel chipsets. In the old days, this type of migration between various hosts within the same cluster would require that all of the servers have the same server CPU and server chipset. Otherwise, the restore operation may not take place correctly. Flex migration provides a compatibility layer in place that allows current and future Intel CPU and server chipsets to be organized within the same cluster so that as you end of life physical servers and replace them with newer servers, you won't need to end of life and replace the entire cluster at once. You can do it server by server. So planned downtime is important because it's oftentimes more common than unplanned downtime. Having a quick way of being able to pause and move a VM to alternate hardware without causing an extended period of downtime so that we can, as IT pros, maintain the underlying hardware. Unplanned downtime, though, is another area that we definitely want to plan for. That's when we have a failure within our environment. In this case, a failure of a single host. And by leveraging Intel and Microsoft Hyper-V features together, we can really provide a very strong solution for unplanned downtime. First, within Intel network interface cards for Windows Server 2008, the drivers support a network teaming feature. The network teaming feature permits multiple physical NICs to be combined together into a redundant pair. So that if it's simply a network failure, a NIC failure, that's part of the issue, instantly the Intel teaming can fail over behind the scenes to the replacement NIC. Now, it's important to point out that Microsoft does not support directly any third-party NIC teaming, because these are features that are supplied by the device driver, the OEM device driver, not by the Microsoft operating system. So while it's compatible and several enterprise customers are using this feature, it is something to be cautious about because Microsoft does not have official support for any NIC teaming from any manufacturer. In addition, failover clustering can be used to combine multiple Hyper-V hosts together into a redundant cluster of hosts so that in the event of a host failure, the VMs that were running on that host can be moved to another host and restarted. With unplanned downtime, there's no way to save the state of the original running child VMs because the host that they were running on failed. So we don't have that nice graceful capability we had with planned downtime of being able to save the state first. Instead, the VMs are moved to a remaining host, and then they're rebooted, they're restarted as a virtual workload on that remaining host. So to give you an idea of the preparation involved for setting up and preparing for quick migration, we have the virtual machines and their associated virtual hard disk files stored on a storage area network, external storage, commonly an iSCSI or fiber channel fan. We implement failover clustering and configure each of the hosts as a node in that failover cluster. And then with Windows Server 2008 failover clustering, the failover clustering manager allows us to pick our VMs and add them as cluster resources. Now, it's important in this architecture to give some thought specifically to memory and disk channels to avoid bottlenecks and other problems based on this architecture. So we want to first make sure that we allocate memory wisely to VMs. What we mean by that is very commonly we've seen lots of environments, if they're running a workload on a physical server that has 2 gigs of memory, when they virtualize it, they'll give the virtual machine 2 gigs of memory, even though it may not really need that. Well, the reason we want to take that into account is that in terms of quick migration, the more memory that a running VM has allocated to it, the more that it has to save the state of before it can migrate it. So we really want to be wise in our consumption of memory. Certainly, we also want to be wise in our allocation of memory so that we can run a larger number of VMs on the same physical server platform. We also want to optimize the disk I/O channel so that it's a dedicated redundant path to the back-end storage itself. And what I mean by that is particularly in iSCSI environments. We see a lot of environments going down the path of running their iSCSI connectivity over the same physical network cards that their front-end LAN connectivity runs over. So we really want to separate that out, both on separate network interface cards at the server layer, as well as separate subnets at the network layer. One subnet for LAN traffic, one subnet for iSCSI traffic. In addition, we commonly also recommend additional network interfaces on each Hyper-V host that are dedicated to management traffic of that host itself, as well as heartbeat traffic for the cluster to determine which of the hosts are alive. So commonly, you might have as many as 4 network interfaces in each of these Hyper-V hosts. A management NIC, a NIC that your child VMs communicate over for LAN traffic, your iSCSI back-end storage NIC, and then the heartbeat NIC used for verifying the running and existence of all of the hosts within the cluster. Certainly, the other feature that the Intel VTC technology provides is acceleration technology, as is pointed out at the bottom of our slide. By taking this approach, it allows VMs to move from one server to the other. So when quick migration is initiated, essentially what happens is that VM state is saved to disk on the SAN storage. That disk on SAN storage is then reallocated to the other host you're moving to so that that host can read and write to it. And then once that host can see and read and write to that disk, it restores the state that was saved from the original host so that that VM comes back online without requiring a reboot in that case. So to give you a demo of Hyper-v. I'm just going to switch back to my desktop again, where I also have failover cluster manager running. So my two servers, server 1 and server 2 that we saw earlier, are both part of a cluster called cluster 1. And in this cluster, we've got the nodes for server 1 and server 2, and some storage disks that are used for cluster and VM resources. What we'll see under services and application is that one of our virtual machines has already been defined as a clustered virtual machine, the W2K8FS1 virtual machine. To define the additional VMs as clustered resources, it's as easy as right-clicking on services and applications and selecting configure a service or application and walking through the high availability wizard. When we get to the select service or application list, we'll see that virtual machine is one of our choices as a resource that we can cluster. And when we select that, it will enumerate for us the other VMs that are running throughout all of the hosts in our cluster that are not currently made high available, that are not currently clustered resources. We simply check those virtual machines, walk through the wizard, and it will bring the storage, the configuration, and the VM settings into our cluster as separate resources, just like it did for W2K8FS1. So we'll see the configuration, the VM settings, and the cluster disk, the shared disk that that VM is running on. Once it's in this state, for planned maintenance, if we wish to move this VM to another node, we simply right-click on that virtual machine, move it over, and we'll see that it'll go through the process of taking it offline, saving the VM state to disk on the original host. So right now it's still on server 1. And then once it saves the state of that VM, it will move the disk over to server 2 and then restore that state. Now, as you see here in our lab environment, our back-end storage is not necessarily optimized for heavy usage, so it's taking a little longer. What we've seen in large enterprise environments is as quick as a 4 to 6 second quick migration with a properly architected back-end SAN for that environment. So while we were talking, our VM is now moved over to server 2. And if we switch back to Hyper-v Manager, we'll see that it's no longer running on server 1. And if we switch over to server 2, there it is. It's running. It's in the same state. If we look at our thumbnail, it has the same windows open that were running before, so it didn't reboot. It just saved the state, migrated it, and then resumed the state. I'm just going to go back to our slide deck here so that we can finish up. So in summary, we've looked at Microsoft Hyper-v server virtualization and the benefits provided at a hardware-enabled or hardware-assisted virtualization layer by Intel VT, both for processor and memory, as well as for connectivity. We've looked at the requirements specifically for being able to utilize Hyper-v on our Intel chipset servers, and we've gone through demos of the installation and management of Hyper-v, as well as high availability with Hyper-v. For more information, I'd encourage you to visit Intel's virtualization community at www.intel.com/go/virtualization. There's lots of great tools there. There's more detailed technical information on Intel VT, as well as an ROI calculator for demonstrating the value of consolidating multiple server workloads from older servers onto a smaller number of newer servers. I'd also encourage you to visit the Microsoft TechNet Tech Center on virtualization at technet.microsoft.com/virtualization. Lots of great tools there for helping us to assess and plan for virtualized environments based on what our data center looks like today, as well as being one of the locations that you can download the free Microsoft Hyper-v server product from. At this point, I'll turn the floor back to Phil for handling our Q&A.
All right, thanks, Keith. And ladies and gentlemen, if you do have any questions for Keith, please go ahead, submit those now. Go to your Q&A menu up at the top of your navigation and select that, then type your question, and then please click the word ask. Do not click the hand. That won't submit your question. Go ahead and click ask. Also, I'd like to remind everyone that you may print a PDF of these slides, and to do so, simply go to the lower right-hand corner of your client, click on the icon of the printer. That will allow you to save or print those slides locally for your convenience. And appearing on your slide area momentarily, you should see the survey for today's web conference. Please do take a moment to fill this out before you log off today. Just simply follow the links with which you registered, whether that was online or by some other means. Please go ahead, if you would, take the time to do that. That feedback is very important to us. With that, I'm going to turn the floor back over to Keith for any questions that may have come in.
Great. Thanks very much, Phil. So we have a few great questions here on Hyper-V support of hardware devices. One question from Darius is, does Hyper-V currently support USB devices being directly exposed to the child VMs? And the answer to that is that currently it does not. However, in many environments, we're able to work around that depending on applications by copying the content of a USB device over to a network share. That USB device access is something that the Microsoft team is working on. We don't have a confirmation on when it'll specifically be in the Hyper-V product release, but it is something that's being investigated for a future release. In addition, William asks, how can we configure multiple NIC cards on the host server so that the host is on the same internal corporate network, but the guests can have varying levels of access to that internal network, where some guests may have access to the internet and others do not. The way for configuring that within Hyper-V is by taking advantage of the VLAN tagging support. When you're setting up the configuration settings for each of your guests, for each of your child VMs, in the settings, when you define the network card properties for that virtual guest in Hyper-V Manager, you're able to associate a particular VLAN tag on a per-guest basis. What that allows is each of the guests to be running over the same set of physical network interfaces, but at a network layer within your network switch infrastructure, have the network separate that traffic out onto different VLANs that have access lists in place at a network layer to prevent access to other areas of the network. In addition, we have a question from Raymond. What selectivity of choices are available for hardware? For example, to install a server for Vista Ultimate desktops, what are the hardware requirements specifically for Hyper-V? So out on the www.microsoft.com/virtualization site, you'll see some information in terms of Hyper-V hardware compatibility guidance. And one of the decisions that the Hyper-V team made early on was to not have a separate hardware compatibility list just for the Hyper-V role, but to instead develop it in such a way that any server that meets the Windows Server 2008 x64 hardware requirements, along with having support at a hardware level for Intel VT and Intel XD memory protection, will be compatible with Hyper-V. From Rodolfo, we have a message on creating a new domain tree within a Hyper-V server host. Is that possible to create a new domain tree in the Hyper-V server host? If we're using the base level Hyper-V server, the free product that's available from Microsoft, because it does not have any of the other network services beyond what's required for running Hyper-V, Hyper-V server does not have the ability to act as a domain controller. Windows Server 2008, though, the full operating system, with the Hyper-V role installed on it, can act at a host level as a domain controller itself. And that's a common consideration in many environments to ensure that a domain controller is available for any of the VMs that are running on top of that host. One way to minimize the load of that configuration in the parent VM, and to get it as close as possible to the very low load of Hyper-V server would be to install the parent VM with server core. It can be a domain controller then. We have a question from Edward. Is clustering supported with a Hyper-V standalone product? No, it is not supported with Hyper-V server. Enterprise Edition or Data Center Edition of Windows Server 2008 is required to support failover clustering. From Danielle, we have a question on what happens if server 1 dies in the clustered configuration. Well, that would be an example of unplanned downtime, and if server 1 should unexpectedly die in that clustered configuration that we saw earlier, any of the clustered VMs that were represented in the cluster failover administrator interface would have their disks transitioned over to one of the remaining Hyper-V hosts, and then they would be rebooted. Those child VMs would be restarted on that host. So it still provides high availability, but because it's unplanned downtime, the cluster administrator and cluster service doesn't have an opportunity to know about it in advance and save the state of that VM. So it does migrate, but it causes a restart rather than a resume. Then we have a question from Keith. What is the simplest configuration available for test engineers to be able to quickly test various operating systems? In the past, Virtual PC was unable to support the x64 OS as a child. And that's a great question. Windows Server 2008 Hyper-V does support x64 as well as 32-bit child VM operating systems. So you can put that in place in a small test environment. We've had some engineers that have run it on equipment as low-end as a laptop that meets the TEL VT and XD requirements and 64-bit requirements. Many of the laptops today have those requirements and can have up to 8 gigs of RAM installed in them to provide an effective test environment that's portable. You'd want to check with your laptop OEM vendor to determine if they meet the requirements for running Hyper-V first, though. Question from Jed on Intel's modular server. Can the blade nodes in that box be configured in a failover setup? Yes, they can. Intel has tested that configuration. Is there a standard tool, from William, a question, is there a standard tool for moving a standalone server to a Hyper-V image? In other words, for doing what we would term to be a physical server to virtual server migration? That's a great question. The included management software that comes with Windows Server 2008 Hyper-V does not have that ability. However, there are a couple options. You can go down the path of taking a peek at System Center Virtual Machine Manager, also listed and referenced on the www.microsoft.com/virtualization page. Virtual Machine Manager offers both a workgroup edition, which is very cost-effective, as well as an enterprise edition, and has one of its built-in features the ability to perform physical to virtual migrations. Those physical to virtual migrations can migrate prior physical Windows Server 2003 or 2008 physical hosts to a Hyper-V child VM, and it can do it in such a way that does not require the servers to be shut down. It deploys a volume shadow copy agent to those physical servers so that an image of the server can be streamed over to the new child VM while the server is still running. Older server operating systems, Windows Server 2000 and prior, do need to be shut down and rebooted from a specific CD that has the migration agent based on Windows PE installed on it. So for prior to Windows Server 2003, Windows Server 2000 and before, those servers do need to be shut down for a P2V migration to take place. In addition, if you're looking in a test environment, also available free of charge from the Microsoft Download Center is the Windows Automated Installation Kit. One of the features that the Windows Automated Installation Kit provides, or WAKE, is to take an image of a physical server and be able to replicate it elsewhere. That might be a tool that you could put together in your environment if you were specifically looking for something that could be customized for a small lab environment very inexpensively. And let's see, we have no more questions there. Actually, we do have one more question from William. If you are running Windows 2008 Standard with one VM, can you add a second VM if you buy another operating system license? And you certainly can. That would be the way of properly licensing Windows Server 2008 in the additional child VMs, would be to purchase an additional operating system license for each of those additional child VMs that are running. For Enterprise Edition, the base product gives you 4 included operating system licenses, so that the first 4 VMs you do not have to license separately. And Data Center Edition gives you the ability to run an unlimited number of VMs without purchasing any additional operating system licenses. One point to note is that any additional product licenses that are running within those VMs, in all cases, still do need to be purchased. In other words, if you have a SQL server that is virtualized as a child VM, you may not need to pay for the operating system license, depending on the underlying host operating system, but you would still need to pay for the SQL Server product license. Okay, so and I think that's all of our questions.
All right. Well, great. Thank you, Keith. And ladies and gentlemen, just another quick reminder. You may print a PDF of these slides. Simply go to the lower right corner of your client, click on the printer icon, and you'll be able to print and save those locally for your convenience. And one more plea, please do take a moment to fill out this survey before you log off. Just follow the link with which you registered, and you should be able to get to that evaluation. And with that, I would like to extend a special thanks to Keith Mayer for his presentation today. Thank you all for joining us, and you may now disconnect from the audio portion of today's conference, and have a great day.